So we wanted to start the discussion by discussing some of the unique aspects of the Arctic system. And both Lee and Joel mentioned that one of the unique aspects here is seasonality, extreme seasonality, and also changing seasonality. So Patty will show you a couple of slides to start the discussion on this topic. And please get ready to ask questions or interact with them with the panel to address this important question for the Arctic system.
So I want to thank Joel and the previous speakers because they brought seasonality. And I just want to gently remind you about how extreme it is. And I'm just going to show a few cartoons of conceptual models. The Arctic folks will go, but what you have here is effectively a conceptual model for the Barents Sea, which is starting at 78 degrees north. So first thing, if you saw all of the maps that are shown up to now, the land-ocean ice zone that we've been talking about is about 66, 60 around here. We have almost very few or no conceptual models that are trying to guess what the changes would be. Nonetheless, I'm going to use most of these, which are ice, ocean, open water regions, to show that. So what you have at the top is before, the current, and the future, and the main issue is one of decreasing ice. What you have here is winter or supposedly darkness to spring to summer to the fall, and the red is heterotrophic dominated, the green is autotrophic dominated, and hence there is a lengthening of the growth period and with consequences for happening to the retreating ice. Two things. This is also happening on land. The second one, ice is retreating, but it still freezes during the wintertime. It's just that the quality and the quantity of the ice are changing. So here, the growth season is longer. Now, the previous slide had the light period in the middle, implying that that's the important time. And for most of us, always has thought we don't look in the Arctic in the wintertime because it's frozen and nothing happens. And so almost all the models include the Arctic in the wintertime stops, and it's got a cap, and so you don't have to worry about it. But what we have seen now, and these are beautiful data from people working out at the University of Tromsø, showing that almost every aspect, from birds to larger organisms, to benthic organisms, to even phytoplankton, which perhaps are becoming mixotrophic, are actually active during the night. Because the night is also, there's a difference between when the sun is below the horizon, but you still have some light, and the period when it is truly, truly dark. These birds actually have filled stomachs, so they're feeding on something. Yeah? There are issues here also for example, the quality of the ice in the middle of the winter. Perhaps the permeability and the porosity of the ice are none. But during the shoulder seasons, which are extremely important, that is the transition from winter to spring and from summer and fall into winter, people actually have measured flux of CO2 from or through the sea ice. That's not in the models. And every time we measure those, we say, nah, we did something wrong, okay? And so what you have here, again, is now you're going from 70 north to 85 north. And here you have the time of year. The further south you are, such as the regions where we've always had the spring bloom, and Joel had this beautiful map, how narrow that river freshet is. Same thing for the phytoplankton. But we're starting to see a fall bloom. which is being shown through remote sensing because we have very few measurements there. However, as we move northward already, that spring bloom is now in summer, in late summer. I just came back from 89.5 north. In the spring bloom happened in the last week of August, in the first week of September, and by the end of the first week of September, freeze-up has started. And there were plenty of ice algae there. So what you have here is this opening ice on both ends. And the development, as many of you may be aware, of blooms which are happening under the ice, which we now think that it's not just simply a modern phenomenon, but it's probably something that's happened for a very long period of time. Data, very few. Consistent data throughout the entire seasonal cycle, very few. Long-term time series of oceanographic parameters in the Arctic, none. Okay? And so here, this is the same cartoon, and now this was another conceptual model, David Barber, showing again the seasonal transition from what we've always known, a bloom at the marginal ice zone, which is now becoming deeper, which perhaps is extending much deeper and much further into time. And this then plume can actually be followed. But if we are to be using remote sensing to detect this, and this is below the top optical depth that the satellites can see, then we don't see it. And so then how do we go, which is sort of what experts were talking about, they're looking at this deeper region, in a world here, which is on top of that, filled with ice. And of course, it's a lot more complicated than that, but Joel did a great job with that one, so I'm not going to talk about that. Thanks. This is just sort of to promote questions, okay? I'm done.
Your questions, discussion on this topic?
Nobody wants to go up there to sample? It's gorgeous. Come on.
I'm Priscilla Leung from NASA Goddard. I have a question, but it's more curiosity because I don't know much about the Arctic. It's about the under ice blooms of diatoms and of the massive blooms they have there. Do they prolong a little bit over winter? This accumulated biomass, is it important to sustain life over the winter? And if the ice is melting and this biomass is reduced over the summer, will it influence the sustaining life over the winter in the Arctic, or is it just doesn't make any difference?
So we have anecdotal information. We see the blooms. The blooms are extending and they can cover enormous areas. In order to be able to know whether that continues and it stays throughout the winter, you would need to deploy instrumentation under the ice. We can do that either very deep or if you're lucky, like the ice tether profilers, which have had some optics to look at falling particles, but they start at 7 meters. Nobody in their clear mind would put something closer than that, as the ice will crush it in ear. But it's hard, really hard to get those data. There are very few sediment traps. The Canadians have put some, but they start at 400 meters. You had that. However, the Germans have deployed cameras all the way up, perhaps 88 north, and seen these clumps of material that is ice algae, something that have fallen in, I'm going to use the word litter, cover the bottom. But we've seen that twice. Is that something that always happened and nobody put a camera? Or is something that is only now happening because there is less snow, more light going through the ice is there, but it's not as healthy, and hence you're getting more? We don't know for that. Thank you. Anybody else?
Bryce Greenert from City University of New York. I think it's more for Joel, but probably for everybody as well. Do you see a role for involving local communities more and getting instruments up there? Because it seems pretty tricky to get samples back and processed in a pretty quick time, and just, you know, you look at the spatial extent of the Arctic and trying to capture all these processes. I'm just kind of curious if there's efforts underway to get the local community more involved and trained, or what the status of that might be.
I could make a stab at it. I think there's a tremendous interest in incorporating these communities would like to see their indigenous knowledge used by Western scientists. I think that's a big challenge. But to just give you some idea of the interest of, we went to Savunga, which has got 600 people, for a meeting, and to discuss our work on clams that walruses feed on. And this is a community that eats walruses if they can get them. And we had 27 hunters show up, and then I was just doing 27 out of 600 people in a community. And I was thinking, well, the place I live, I'd have to have 2,300 people show up at the county that I live in to show up to hear my research, and that's not going to happen. So there's a tremendous amount of interest, and we do have some challenges because these communities are doing subsistence hunting, that they depend on the food they can't afford to, or they'd rather not go to the supermarket and buy stuff. They want to harvest food, and so there is a challenge, and they see that as different than being employed to collect samples. I think particularly in Barrow that's done, that there is a little economy that supports people working for scientists and helping scientists get the data they need. But we still have a long way to go to make that work. I'm sure some Jessica.
I would second that. The comment that I'll throw out is that it's a question of scale. You know, these small communities don't have big infrastructure. You know, when you're a community of 2,700 people, or when you're a community of 200 people, you don't have a large ferry or a ship that is stopping near your particular port every day. And so the idea that you would have a big boat that's capable of deploying any instrument of size is a challenge. I think they would love to help us, but the infrastructure just isn't there. I mean, it's the Wild West. It's the middle of the Arctic swamp. One of the other challenges that we have is that coastal Alaska is enormously shallow for a really long way. So the small boats that can service the very near coastal regions often aren't very well suited to the kind of very far offshore deployments that we need them to make, even when it's just dropping a glider in the water. So I think that the willingness is there. The partnerships are really starting to emerge. Lee and Jackie are definitely very diligent on the front lines, I would say, about incorporating native and local communities into their research, but especially as it comes to oceanography, it's a challenge. They want to join us. They want to get on our vessels. They want to be collecting their own data, which is really fun, but, you know, resources.
If I can add, our Canadian colleagues, they're mandated to do that. And so it's part of their economic development to do so. Some of the communities, however, have an intrinsic distrust of the Western scientists coming in and us telling them what they need to do. And so some of the communities have enough resources. They've gone and hired their own scientists to do the same type of research that we're doing. But if anyone here thinks that you're going to go there and just do it, you need to get a permit from them. And if they say no, it's no. End of story. So you have to be very respectful when you go. And you may think that you're going to go and find a dock and that there will be power at the dock. First, there won't be power, there won't be a dock, and there won't be any fuel either.
There may not be a crane. Can't lift anything.
So it's even if you go into Barrow, or some of the bigger ones, you can't really get on a ship on Barrow. You go somewhere else and you can go all the way around. So I won't get, it's part of Jessica's presentation. So.
Yeah.
I think it's right that you have to make it relevant to them, because on the NG Arctic, one aspect is that it's really focused on carbon cycle, and frankly, not too many of the natives really care about that, because that's not something that provides food for them or takes care of hunting. And they also, I mean, we have people measuring leaf, chlorophyll, things like that. I mean, it's really esoteric. And so part of the motivation for DOE on the new interface project is actually trying to make our science somewhat relevant to people in Alaska, not necessarily as consultants, but at least so that when we present our results, they see something that, okay, this is federal dollars being spent in Alaska. It's not just to entertain a bunch of people from the lower 48 because they think that's really cool.
Hi, this is Wei Jun Cai from University of Delaware. So we see that the Arctic Ocean is getting fresher with more ice melt, with more Pacific low salinity water coming in, and maybe more river water. So the question is, do you see the Arctic, as this trend going on, do you see Arctic Ocean gets more stratified or less stratified? Because with fresh water it could be stratified, but with wind mixing, it could be less. So, and this is important for carbon cycling, biological production.
Yeah, no, I think it's the easy, or the default answer is it's got to be more stratified as more fresh water seals that salty layer below.
I think it depends on where you're talking about, because as you lose sea ice, or as sea ice moves further and further out of the way, you're increasing the capacity of wind to overturn the ocean. And especially in the Pacific Arctic, we've seen an uptick, a very clear trend in increased upwelling and vertical overturning. So obviously that is something that erodes stratification. So I think that signal is probably seasonal. I think it's probably spatial, and there's a lot of variability to it. I'm priming the room for my presentation coming up here in just a second.
I think this is a good time for us.
Oh, hey, can I cue myself?
Jessica,
I think you were supposed to do that.
We're discussing about the need to capture seasonal cycles. We've been discussing, however, also how challenging it is to have these observations in the Arctic. It's a remote environment. It's often inaccessible. So Jessica is going to be discussing a little bit more about these challenges of observing these processes in the Arctic.
Right, so the room has had the opportunity this afternoon to hear a lot about the impacts that melting sea ice has had on the Arctic in a variety of ways that increased river discharge has had. We're talking about melting permafrost and coastal erosion, and I want to leave the room with one very simple statistic. Arctic basin sea ice is declining. Here's the current trend just from June of this year. It's not just equivalent to 1 Texas worth of sea ice melts, it's almost 2 Texases worth of sea ice melt. If you leave and you remember nothing else, you can remember almost 2 Texases worth of territory that we need to consider covering. Obviously, when you change this much territory, just think about it in terms of space. 2 states of Texas. They are obsessed with being huge. 2 states of Texas in the Arctic. It's enormous. Obviously, that has implications for carbon flows, both near shore and offshore, export of carbon to the deep. It also affects things like sea air exchange. But often this is pretty complicated, right? I'm showing a very simple statistic to help you understand that things are complicated. So this particular picture right here is actually of a sled team that is dragging their sled on meltwater on top of ice. So this is a unique system that is one that we rarely think about, right? How do you model air-sea flux through sea-air interface, through the ice-meltwater interface, through the meltwater-ocean interface, through the layers of the Arctic Ocean underneath that? How do we even begin to test and understand that, given that this is also, even though it's taking place over a huge area every year, extremely difficult for us to access and sample, even when we do have the tools that are capable of doing that. I mean, it's absolutely insane. It sort of feels like walking on water. Yeah, Science puns for the win. So I spend a lot of my time thinking about how we can actually make these observations. This is a huge area that we're trying to cover. And it's changing very rapidly, it's highly seasonal, it's very spatially variable. So how do we use the tools that we have in our toolbox to actually get out there and make these measurements? So what I'm showing here is a graph that along the x-axis has units of space, and on the y-axis has units of time, and each of the boxes in here show sort of what the imprint of any particular platform is. So for example, a mooring may be able to tell us something on the scale of, about 10 meters worth of water from any one particular point, but maybe we have mooring records in the water all the way up to 10 years. So that's this red box right here. Across all of the different tools that we have, if we include things like satellites, we have a very good chance of seeing the surface ocean. But this doesn't include depth. It doesn't necessarily include resolution, right? A 10-year mooring record may be intermittent, especially in the Arctic. So I'm starting to develop tools that sort of fill the gaps between these different scales of observing. You may have heard me a couple of years ago speak about the sail drone. This is a surface platform that is capable of moving very quickly, and we sort of think of it as the in-between of a mooring and a ship. So it's helping us fill that interim scale so that we can collect more information. We also work with fixed platforms that are now starting to crawl up and down in the water column called the Prawler, and that's sort of extending our fixed platform box by 1 degree of magnitude over to the right. So anyway, even when we have all of these tools that are capable of making measurements at the resolution we need, across the time series that we need, that can handle the space coverage that we need, there are still challenges like, how do you handle depth? There's still challenges like, well, what about my particular pet parameter that nobody has a sensor for yet? I have one of those. So, I think one of the best opportunities that we have in the meantime when we're still trying to scale up this observing system, and again, I can't express to you how big this area is and how few measurements we have to actually fill those observing gaps. I think one of the best opportunities we have is to start working more efficiently and effectively with the modeling community. So here's an example that's coming out of my lab this year. This is a study that's being headed up by Chidong Zhang and Shell Gentleman. Effectively, they're using the sail drones to try to access the sea ice edge. We want to be sailing back and forth across the marginal ice zone in that low salinity, actively melting territory right there next to the sea ice so that we can better understand uncertainty in some of the reanalysis products that are used to initialize sea ice prediction models, so that we can better understand whether or not satellites are collecting good surface data at the interface between things like sea ice and ocean. We think we're doing a pretty good job because we keep getting stuck in the ice. Initially, we were concerned that we would never get close enough to actually make good headway on making these measurements. Effectively, we'd just be making open ocean measurements and wouldn't access the MIS, but you know what? The wind is taking care of that for us this year. So anyway, so that's sort of what I want to leave the room with, that I think that this is a very big, vast observing challenge, that we're not going to be able to scale an observing system up for anytime soon. So how do we collect targeted observations that help us validate satellite observations, that help us validate models that can, in the meantime, help us start addressing some of these questions and forming some of the kinds of conceptual models that Patty showed earlier? How do we get from just understanding the sea ice, air, carbon exchange interface to air, meltwater, sea ice, surface ocean kind of interface? I will throw it to the room.
So if I can say, I think almost everyone in the Arctic community got the pictures from the gliders as they went, and they did not really want to get close to the sea ice, but they were right in the sea ice, and Yep, that's
Part-
where they were.
Part of the observing challenge in the Arctic is that ice is a mechanical hazard. It crushes things. It kills people every year. We lose millions of dollars worth of equipment. I mean, it makes it exciting, but it also makes it really dangerous. And so we want to be keeping our equipment and our people as safe as possible.
For years, we've spoken about marginal ice zone. Now we are all starting to talk about seasonal ice zone. And that extends anywhere from meters to hundreds of kilometers these days.
I'm Mike DeGrampre from the University of Montana. Back here.
Where are you, Mike? Hey.
I wanted to let you know we have PCO2 records from moorings and ice tethered profilers and ships since 2012 in the Canada Basin, and they're publicly available data sets from the Arctic Observing Network funded by NSF. So you can check out those data sets online that we've been generating for 7 years now.
And you have atmospheric CO2 concentrations, atmospheric bromine oxide, and ozone concentrations. These are in the chemistry end, as well as complete meteorological concentrations. But all of these are on the pack ice. In this whole
Those are Patty's data, yeah.
conversations, which are publicly available, 10 years of data, are not at the land, ice, ocean interface. That's a tough place to sample.
Graduate students excited about moving into this field yet? See how much work there is to do? Please, will you help us?
David Ho from University of Hawaii.
Where are you at? Oh, hello.
So I'm a bit confused because on the one hand, I feel like you're sending me mixed messages or sending us mixed messages because on the one hand, you're saying, come sample the Arctic, it's wonderful. And on the other hand, you're telling us it's impossible to do it.
Yeah.
So what?
Both things are true.
Okay, leave it at that.
So how would we go about doing it if it's so impossible?
Carefully would be my sort of pat response, right? I think that we need to be targeting our observations. The goal is not universal coverage. The goal is to better understand the mechanisms that we know are there, to target areas of unknown so that we have the capacity to see some things that we may not know we are missing. And then I think that we need to prioritize time series, like Mike has pointed out, that are going to help us understand some of that long-term change, to refine my message.
So David, that's the whole premise behind Arctic Colors, is to do it in an organized, sustained, cost-effective manner that will allow many in the community to participate and hence scale it up while sampling different systems given the heterogeneity of the processes that are applicable. So what can you do? You can contact your NASA program manager, your NSF program manager, your DOE program manager, your favorite foundation, in order to say that such a sustained effort is what the community needs.
Well said.
Good. Did you want to say something?
Briefly, I think I think back to when I was a graduate student and how little we knew, and now there is a lot of data. We're making some progress, so in many respects.
Yeah, I had a question for Lee. I'm Ray HR from Penn State, and I'm sorry if I missed it, but I heard that you say that there's an increasing flux of fresh water from the Pacific into the Arctic through Bering Strait, but I didn't get the mechanism, if it's known. Is the total flow increasing?
Well, there's a pressure head between the Pacific Ocean and the Arctic, that the elevation is higher, and you hear different explanations of it, but essentially there's more freshwater falls on the Pacific Ocean, and I've heard it talked about even in the sense of moisture in the Caribbean being carried over the Isthmus of Panama. That's a transfer of water from the Atlantic Basin to the Pacific Basin, or in the Pacific Northwest. It rains so much that water piles up and only has a few places to go, and so just like the rivers are increasing in discharge, the rivers in the North Pacific are probably increasing in discharge and causing that increase in flow.
Thank you.
What about UAVs as a tool for some of this work? Has that been, I know you need people up there to deploy them, but that technology keeps getting better and better. And for the sorts of questions that you're asking, I'm wondering if that could be useful.
Can you give me a better qualification of what you mean by UAV? What specific UAV are you talking about, or form of UAVs you're talking about? Tethered, untethered?
Untethered drones is what I'm talking about. Yeah.
So is Craig in the audience, by the way? Craig Lee? No. Okay, so Craig Lee, a researcher from the University of Washington, is trying to fly gliders under the ice. It would be an amazing new opportunity for sampling around the Arctic Ocean, and especially in the marginal ice zone. We're getting pretty good at doing it in Antarctica. The ice in Antarctica is much more predictable than the ice up north, just by virtue of the way that the winds and the ice behave down there. So what we are trying to do now is understanding that, in the Southern Ocean near Antarctica, we can use acoustics and other mechanisms to detect where the ice is and say, oh no, and have your glider turn. And it can essentially govern itself. The ice is moving a lot faster up in the Arctic and is a much bigger challenge. So you need to be able to navigate essentially by GPS. We need to know where the glider is at all times so that we don't lose it, so that we know where it is collecting data. And so Craig has started to put acoustic ping arrays into the ice matrix to help navigate underneath the ice and actually collect valuable, usable, spatially located data. The challenge with that is that those acoustic arrays have the potential to impact whales, and the local communities are super not into that. So figuring out a way to actually develop this technology with respect to the communities that we are working with is challenging for us. But we are pushing forward with new frequencies, with low impact ways of doing this kinds of research. Lee, you may know more about that.
So let me also clarify, that's great. But also I'm wondering about aerial vehicles, like so flying over some of these regions to map out some of the sorts of things that you guys are talking about. Yeah.
As much, although Alaska was one of the states that's permitted to do this by the FAA, and there are people using those vehicles in Barrow.
What he means by permitted is that in most areas around the country, you have to be within line of sight of your drone to fly it. Alaska is exempt from that in many cases. Not in all cases, but in many cases. We still rely a lot, sorry, Lee. We still rely a lot on manned flyovers. We're starting to drop floats from aerial vehicles at PMEL. That's Kevin Wood's work. I'm up here taking credit for a lot of different people. I'm up here directing you to the research of a lot of different people. But
yeah. So folks in the Canadian Arctic and in the European Arctic have used it and are using them. Relative humidity and cold are not very gentle with anything that is flying. In other words, just any one of us who flies, if there's a little bit of ice, you spend an hour or more de-icing your plane, it takes almost nothing. So you need to fly them with the full understanding that you're going to lose it. Yeah? But having said that, if there is a way of getting them back, yeah, they do great. And it allowed to, for example, get an idea of the lead density around, let's say that you're on a ship and you cannot look, so you can do that, tens of kilometers without necessarily having to deploy a helicopter, for example. And the second point is that there have been biofloats deployed in the Arctic. They are equipped. They are the same biofloats that were spoken about yesterday. They have an ice avoidance algorithm. There are two things. They're capable of surviving winter, No, Chris, Nico Mayo presented some data. Those are all in the Greenland Sea. You may lose it. You may not know because there's no GPS contact once they are under the ice, but they can deliver beautiful 24 months, 36 months of data. You don't want them in shallow regions. They don't know what to do with sediments. No, the SOCOM entire experiment is deep ocean, not coastal ocean. It's the same thing that happens with the gliders. Nobody really wants those gliders getting too close to the coast. So that's, can you? Yes.
You mentioned increasing the relationship or modelers with the observationalists, and I think that there is a new Aussie program, NOP, that's being funded. Can you speak a little bit to the state of observing simulation? I can't remember what the acronym is for, but essentially using models to test what are the key observing locations, choke points, regions, that a time series that you need to improve the model simulations.
And Joel. Anybody else want to take this one?
So I can't speak to that program, but DOE, one of the mantras that they now put in the NG Arctic project is they like the term MODEX, which is model-inspired inspirations or model-driven experiments. And part of it was coming out of, the NG Arctic came out of their FACE program, which was forced air and carbon simulations where they did ecosystems, and they were going to go do that in the Arctic, and they were persuaded that it wasn't going to be very feasible. But part of it was their real emphasis on climate and Earth system models. The modelers were looking at these vast data sets that were being collected and saying, well, we can't use this data. It's not collected what our models do. It's not where it's get. So within the sort of almost any project now that gets proposed to DOE, at least with observational component, it has to have a very clear model coupling to it. The feedback to that idea hasn't come through quite as strongly. The modelers aren't at the point because we're really trying to fill stuff that are missing in the models or improve what's already in the models. And so the feedback, I would like to see it stronger, but it's not really there. Okay, you should go measure at this spot is less rather than this process. And so there's not as much right now that, okay, this is where we're missing. And part of it is a lot of the models on that have been on the land side. On the ocean side, I'm not really sure in terms of the sea ice or ocean side whether there's been more of that. But there's really an emphasis, at least within DOE-funded observation programs, to make them relevant to the models.
Wow, I ended up with two microphones. Speaking to them both. The follow-up note that I'll make on that is my closest collaboration partner is a modeler. And my goal is to be able to, as much as I can, conduct regular time series observations that also target processes that we know have a really high uncertainty in the models. One thing that I am hearing from that community more and more is that they want mechanistic projects. They want process studies so that they can adequately model particularly a rate. So they're not looking for a volume, they're not looking for a data point in space. Very often what they're looking for is a rate that can be easily generalized and incorporated across models. Rates are hard, for any carbon chemist that's tried to do, pore water respiration experiments can tell you that.
NASA Ocean Biology and Biogeochemistry has historically funded a model intercomparison or algorithm intercomparison to derive chlorophyll in prime production. And there were two such exercises ran in the near past. One comparing almost every ocean color algorithm to derive prime production, and the other one was a comparison of regional to Earth system models. And again, the issue was to compare with real data. It was not a beauty contest. The whole point was to improve all models. The things that came out to be the most common limitations to all of them were mixed layer depth. These are all friends. Nutrients concentrations throughout. Not necessarily euphotic zone. They did pretty well at that. not necessarily sea ice extent or concentration. And so with that, there is enough sensitivity studies there to then allow all of the models to move forward. One of the biggest difficulties was, what data do you compare with? And like you, I hear this a lot. Patty, the data don't exist. They do. They're just not a nice reanalysis type or a database where everything has been nicely averaged overall. And those are not sexy things to do. Yeah? Rates? Yeah, rates.
Hi, Matthias from UBC Canada. Have you looked into collaborating with communities for proxy kind of data? For example, using their fisheries landings to reconstruct possible productivity because they have seasonal fisheries cycles. These communities eat fish. So do you have any other kind of proxy data that you could get in collaboration?
Well, there's a lot of interest in marine mammal, at least in the communities that we work in or work near in Alaska, that there's a lot of interest in eating marine mammals, and so there's statistics kept on harvests, and actually the hunters in some communities donate some of the tissues that they're not going to eat or choose not to eat, and they end up, say, in the University of Alaska Museum, and I have a graduate student who's looking at IP25, this biomarker in walrus livers now, to see how dependent are walruses on sea ice, since the sea ice is disappearing. So yeah, we don't have as many fish, but just as an anecdote, that maybe the fish are going to become more important. I mentioned Savunga, and ran into a friend of ours from Savunga who was in Washington, D.C. talking to Senator Murkowski, and he said, oh no, he'd gotten a commercial fishing license because they were getting big pollock this size at St. Lawrence Island, and the water temperature's warmed up. It's no longer so cold they can't go to the northern Bering Sea. Yeah.
So some of these changes, here we're doing geochemistry, and there is some conversation about population. But for example, on the Atlantic-influenced Arctic, the fish are moving. The fish are no longer in the Fram Strait and in Norwegian coastal waters. The fish are moving into Russian coastal waters. And so there are issues of defense, economical issues. Whose fish are those? Yeah? And so I've always fished those fish, but now they're on the other side. They're diplomatic. So these are major political, economical issues which are being discussed under the aegis of science by the Arctic Council, for example.
So I'll jump on the back of that and say that, one of the reasons that it's so important now that we start working with models, with these regionally forced models, is because that's the kind of data that a decision maker is used to seeing. They want this nice, high-resolution map that clearly communicates the one parameter or the one idea that they want to look at. Fish populations. I want to look at a surface map of the Central Arctic Ocean, and I want to see where the pollock are, and I want to see where all of these other things are when they exist, right? And so these are not things that we have the data to create. We have some data, as Mike pointed out, as everyone on this panel has pointed out, but not necessarily data at that kind of resolution. And so to answer these very political, very decision-maker-driven questions, we have the opportunity to steer science in this different direction.
Will Barrelson, USC. You might be surprised by this question. It seems like the Arctic begs more than ever anywhere to be studied from a sediment perspective, both in terms of the huge area of shelf and the very wonderful work that's been done, but so limited with respect to that huge area, changing sedimentary input, with every minute that goes by. And then why and where this proxy question can't be then investigated in terms of sedimentation. Is there anywhere in the Arctic a suboxic, low oxygen sedimentary deposit from which we could start to reconstruct temporal changes from the sedimentary package, as has been so incredibly illustrative for the Cariaco Basin, Santa Barbara Basin, and other laminated sedimentary systems.
Do you know?
I don't know where to pinpoint an anoxic.
I don't know. I really don't know.
Greg's going to tell us.
Answer's over there.
Whatever. We already answered it, thank you. Yeah, the contract program has force across the whole basin. And the problem is. Microphones work when you put them here, no? It is not working. I don't have to turn it on.
Well, Will, I concur that, I mean, they're cores, but your question was specific to anoxic basins, and I'm not sure about that. That we used to think we found places in Bering Strait where there was so much organic material that it was black and stinky, but then when we went back to look for it again, we couldn't find it. So.
Yeah. No, you're right. Definitely there are anoxic sediments. I could show you pyrite profiles from a couple theses, but it's hard to find. But there's a lot of, there isn't at least I don't know of a good in waters we can access a good basin that has an undisturbed record. All these other ones around Barrow and that, they just have these turbidites, if you will, drift deposits. Do you have a question?
Hi, I'm Hua here. Susanna Neuer, Arizona State University. Patty, I really liked your image of this extreme seasonality and the life of the Arctic at night during the winter. I think that's really good to remember that is happening. I wanted to ask about the transition that you call the shoulder region of spring to summer or winter to spring, and the precipitation that falls and the change in precipitation from snow to rain, right? That makes a big difference because once it rains, the snow melts on the ice and the light field through the ice changes. The sea ice communities may export. The phytoplankton below the ice has suddenly a lot more light. And so, I don't think we really commented on that aspect.
So many of us have been asking, the prediction is that with warmer climate, you would have more moisture, whether it is being transported or it's being evaporated or sublimated locally, and that hence would lead to more snow, even though there might be less ice. But the people from the USGS, and I'm looking at Lee here as well, who actually have had snow depth measurements on land for a long period of time, are not necessarily seeing this snow. You have the ice going down, and hence you would have the snow going up. That's not necessarily the case. And from the perspective of snow on ice, that's a really difficult measurement to make. The ice mass balance buoys that Jackie Richter-Menge and Don Perovich have, those are all sub-ice. So in the ice and sub-ice with a little periscope on top of the ice so that it doesn't get crushed neither by the polar bear nor by the storm. So there are remote sensing products coming online to try to get at that. And hence, some of the NASA venture campaigns that were funded were specifically to cover the missing period between the GRACE 2 and the GRACE 3, I can never remember which one it is, which is the satellite that would give us those type of data. So it's not clear that there is necessarily an increase in precipitation, whether it's solid or liquid. That's all I know.
Yeah, and I guess Brendan Kelly, done all this work with ring seals that need snow on ice in order to breed and have their pups, and there's clearly a problem with that. So the snow is disappearing earlier in the season, So your point is well taken, but I think I trust what you're saying, Patty, too, is that that's a difficult thing to get a handle on a large scale from a satellite.
Hi, Chris Sabine, Hawaii. I'm just thinking of potential observing opportunities, and soon enough there will be commercial shipping traffic through the Arctic. And I'm wondering if anyone is talking to those companies that are likely to be transiting through that area routinely about putting underway systems on, or whether we can perhaps work on getting international agreements that this new traffic through ecologically sensitive areas maybe would be required to take some environmental measurements as they're transiting the area so that we can get some more data.
We probably need to speak Russian to those people that we'd be putting those devices on boats. There is some LNG traffic already from the Russian north. Several they've ice strengthened tankers and sent them to Korea and Japan. So there is a growing market. But yeah, I think it'll probably be first in the Russian Northern Sea route. So I don't think that's those steps. Yeah. Yes. Yeah.
I guess the comment that I'll make is that we do that when they're U.S.-owned vessels, right? So there's the ferry system in Alaska is equipped with underway observing equipment, and we're starting to make observations in and out of the fjords in some of these very near coastal areas. But we will be waiting to see which vessels, as Lee said, they will probably be Russian vessels at least at first, and which companies really start scaling up that observing. Right now it's really spotty. You know, even the Crystal Serenity, the cruise ship that's running the Northwest Passage every year, doesn't run every year successfully all the way across. So,
I think that they're called the World Ocean Council, World Ocean Organization, which is only private companies, and their Arctic component is extremely active in meeting. They have their own science meetings, and they're keenly aware. We were just talking, we get their emails all the time as they're trying to reach to the scientists. They're keenly aware, at least in paper or in email, of their responsibility to take care of the Arctic, as at the same time they're really pushing for all of this possible commercialization. So it's by attending and contacting them that they are. IMSCIP is one company which is based in Iceland, and they already have PCO2 sensors that already go from Iceland to the US. No, these are NOAA folks, and that nobody knows. They're just actually hidden in the bowels of these ships. So to a certain extent, it may already be happening for some things, quietly.
let's have a session.
Great, thank you.